I'm Officer Cadet Martinez Chung, and in this lesson we will learn about pressure systems. Alright, so pressure systems. First we have what we call a low pressure area. This is also known as a cyclone or a depression. So what happens in this system then is the wind flows counterclockwise and inward to the center of the pressure system. As you can see right there. The pressure here is lowest at the center of the whole system. And usually you can expect poor weather. So in this area, we have relatively lower atmospheric pressure. And this is usually what happens when there's like storm, rain, snow. Usually you have some sort of low pressure system there. So they're not really as fun. Okay. Another thing we may have inside of the pressure system is what is known as secondary low. Right? This is a smaller disturbance of cyclone nature. Again, remember cyclone is a low pressure system. These usually form within a main depression. So think of a low pressure system within another low pressure system. That's what a secondary low is. It doesn't really happen often, but it's there. Alright, so next we have a few definitions here. So first we have what we call a trough. So a trough is a U-shaped area of low pressure with higher pressure on either side. So if you kind of try to picture a little bit, think of an area of low pressure in the center, and that area is sandwiched between two high pressure areas. That's a trough. Next we have a ridge, which is similar to a trough, but in this case it extends outward from a high with a lower pressure on either side. So it's kind of like a reverse trough with a little bit of a high pressure air system kind of extending into the middle and being sandwiched between two low pressure systems. Next we have a col. What a col is a neutral area between two highs and two lows. So think of like the highs and lows being at four corners in the square, and they all kind of balance each other out once you get to the middle of the square, and that's a col. Alright, next we move on to the high pressure area. So a high pressure area is also called an anticyclone. In this case, the wind actually flows clockwise and outwards. And we have the highest pressure in the center, and this is usually the one where you can expect nicer weather. So if you have a nice blue sky, sunny day, chances are it is a high pressure system. So from this you can see how wind is still working the way we usually know. So wind always moves from high pressure to low pressure. In this case, the high pressure air is moving away from the high pressure area, and it's usually sucked up into the low pressure area where air flows inwards. Now, the thing about direction inside of the pressure areas is a common question, and you should remember that. The way to remember this is through the saying, the clock is higher than the counter. With that saying, then we can say that since the clock is higher, that means the high pressure area has the winds in a clockwise direction. Whereas the counter is lower. So that means the low pressure area has winds flowing in it in a counterclockwise direction. And here's a graphic what we discussed. So secondary lows, ridge, col, trough. You can kind of see a little bit. It's not the best picture, but it gets the job. Alright, next up we have winds. So, again, like we discussed before, air always moves from an area of high pressure to an area of low pressure. And the result is winds. That's essentially what's happening. The air is moving from the area of high pressure to low pressure, and that's what you feel as wind. Okay, now we're going to discuss the factors that actually affect wind. First is what we call the pressure gradient. The pressure gradient is a change in pressure over a distance, measured at right angles to the isobars. In English, it means how much pressure is changing as you move from one place to the other, such as, let's say, ml to calorie. Then you measure the difference between the two, and that will be your pressure gradient. So, the pressure gradient is steepest when the isobars are close. So, I don't think we discussed isobars yet, but isobars are areas where pressure is equal. Iso meaning same, and bars meaning pressure. So whenever the isobars are really close together, so the pressure changes dramatically as you move through the earth, then that's when you have very, very strong winds. So you have a steep pressure gradient that gives you strong winds because the pressure is changing rapidly. So again, like we stated, this determines wind velocity. In contrast, if we have the pressure, the isobars further apart, then in that case, then we have lower wind velocity because the pressure is not changing as rapidly. Coriolis force. So the Coriolis, we don't really call it Coriolis force, it's more the Coriolis effect. But what this does is, this is the result of the rotation of the Earth. So as the Earth rotates, there's a bunch of weird physics stuff that happens, which affects our winds. The result is, at least for us in the northern hemisphere, is that the air is deflected to the right until it flows parallel to the isobars. So air actually doesn't go in a straight line. It's ever so slightly deflected to the right. As you can see in this picture right here, because the Earth rotates counterclockwise, and physics, inertia, and rotational bodies and whatnot, then the wind will tend to be deflected to the right slightly. Alright, next we have surface friction. So, surface friction is the friction between the surface of the Earth, so the ground, and the atmosphere, or the air. This will tend to slow down the air a little bit, which is why when you have very rocky terrain, then chances are the winds are not going to be as strong than if it were like very flat plains. So what this does is it increases the angle at which the air crosses the isobars. It just deflects them a little bit. Alright, by Ballast Law. So this is an interesting one which you can actually test at home. So in the northern hemisphere, when you stand with your back to the wind, the low pressure area is on your left. So let's say the wind is coming from this direction. With my back to the wind, I stick out my left hand. That's where the low pressure system is. And the reason this is because if you remember, the direction where wind flows around a low pressure system in a counterclockwise direction. So if it's hitting your back and it's going counterclockwise, then your low pressure system would be on the left. Go ahead and try it at home if you like. Alrighty, and that's all, folks. So, if you have any questions, comments, concerns, queries, or random outbursts, feel free to put them in the comment section down below. Thanks for watching, and happy landings!